Hey everybody, this is Alex Merced from alexmercedcoder.com, and welcome to this video, which is day 19 of our 100 days of Go and Rust. So here we're going to continue on the Wasm bandwagon that we started yesterday. So we're probably going to wrap up the tutorial in Go, and then we'll see how far we get along with the tutorial in Rust, and maybe even do another day to finish that up. But let's see here. So here's the tutorials that we've been working on. Okay, so again, basically this is straight up from like the Rust documentation for Wasm at rustwasm.github.io. So you can see the URL there in case you want to go check that out. And then this is a tutorial at golangbot.com. But essentially, where we left off with Go, let me just open that folder up. We had it where we could run the server and then see our console log that was written in Go. So let's actually just kind of reiterate that. So again, just to kind of, we had two sort of projects. We had our Wasm project, which just had a main.go. Okay, and essentially what this did is it just printed Go WebAssembly. Okay, it was really like a console log in JavaScript. And essentially, we compiled that to Wasm, and that ended up getting saved in our assets folder. So that created this json.wasm file. Then we created a server, okay, that's going to run, and then that's basically a server that's just going to serve static files. So see, it's a file server, so it just serves the assets in the assets folder. So we created an index.html that has some JavaScript glue that glues our Wasm file into that HTML file. This is the JavaScript. This is that JavaScript glue file. Again, that's something that was already existing inside of our system. We just copied it over here, yeah. So this basically runs that Wasm file that was basically produced from Go code. Okay, and again, the benefit of Wasm is you can write code in any language, compile it to Wasm, and do all sorts of cool stuff in the browser if you need to do so. But there's still more to actually give something with a little bit more functionality. So essentially what we're going to do is we're going to add this function here over to our main.go in the actual Wasm folder. So let me add that. Okay, and let's just like walk through it. Okay. And it's going to complain about that. That's fine. Okay, but let's see here. We're creating a function called pretty.json because the purpose of this is that it's going to format JSON that we send in. So it's going to take in a string, okay, and it's going to return either a string or an error. So what it does, it creates a raw interface. An interface of nothing, like if you pass in like nothing to the interface, everything will implement that interface. So technically it just means anything. So keep that in mind. So if error equals JSON unmarshal, so in this case what we're doing is we're parsing the JSON. We'll receive an error if there is an error. And we're saying if there's an error, then you're going to return the error. Otherwise, you just keep moving forward. We then have, let's see here, if JSON unmarshal, so that just means if it's proper. Basically, we're just checking, is it proper JSON? Okay. Because this will error if it's not. Now what we do is we do pretty error, and again we might receive an error, but here we're going to get the pretty version of the error. So this is going to do json.marshal indent, okay, and then here we're passing in the raw string. Actually, let me think about this unmarshal function for a second. Giving a byte, we're passing in the input. Okay, and again, this is the raw interface here. It just means anything. So essentially, this is just like a placeholder for the data. Error not equal to nil. Okay. So essentially, we're just basically turning this into an array of bytes. Oh, okay. I see what's going on now. Got it. One moment. Let me just repeat that. So essentially, what we're doing here is that you're passing in a JSON string. Here we're parsing the JSON string and saving it in this raw variable, which again has an empty interface, which means anything. So like basically typing something as any. So we're saving the array of bytes that gets created from this unmarshal into here. So that's the raw bytes of JSON, which we can then turn into JSON by saying, but we're using this marshal indent function that adds just some formatting to it. So we're taking the string that's saved in that raw variable and giving it in basically taking any blank space like this and then giving it this indentation. Okay. Now if error, okay, that's if there's an error, and then we return the string. So we basically take that pretty set of bytes, because again this is going to end up being a array of bytes, because that's what ends up being put in there. Because basically we're storing the result of parsing this into here, and then we return the string. Okay, cool. So that's what that function does. So now let's see what it wants us to do. If the string where I get all that, exposing a function from Go to JavaScript. Okay, so now we have the function ready, but we are yet to expose this function to JavaScript so that it can be called from the front end. Go provides the syscall.js package, which helps in exposing functions from Go to JavaScript. This first step in exposing a function from Go to JavaScript is to create a func type. Func is a wrapped Go function that can be called by JavaScript. The func of function can be used to create a func type. So add the following function to our main function here. Okay, so let's copy this over and we'll go through it. And is it going to complain about anything? No, okay. So essentially, let's read through this. Func JSON wrapper, which is a js.func type function. Okay, surprised I don't have to import anything. I'd assume I'd have to import this. I'm going to import that just in case. And I'm going to import JSON just in case, because I find it hard to believe that it's going to compile correctly if I don't import JSON in here. Okay. And do I see anything else that I need to import? No. Okay, so js.func, that's a type, so it's just a function from this library. So again, this particular library, syscall.js, is there for the purpose of, again, binding functions to JavaScript. Func of, so essentially JSON wrapper. So JSON func equals js.func of func. This is the JS value. Args, JS.value interface. So let's think about that. Okay, so func, so we're saying we're wrapping this function here. And this function is basically a signature of, it takes a value, two JavaScript values. So this is args and the original func array. Okay, so I'm assuming this is kind of like holding the array of all the other arguments. So if the length of arguments is not equal to 1, invalid, no arguments passed. Okay, and again here, and then this is the definition of the function. So this function is going to return literally anything. Okay, again, interface of, an empty interface just means really anything. Okay, so if length of arguments is not equal to 1, return invalid, number of arguments passed. Okay, input JSON equals args 0. Okay, so it's going to represent basically this, or actually the first. Oh, I see. Okay, so this is going to represent like this, like the prototype. Okay, so these are just all the actual arguments of the function. So this is the function object. This is the function object in JavaScript. These are all the arguments that we're passing to it. And then we're saying, hey, the input, so generally the JSON should be the very first thing we pass in the arguments array, and which should be a string. So we're going to say args.string, turn that into a string. fmt.print input JSON pretty, and then here we're using the pretty JSON function, input JSON, and if error does not equal nil, okay, then enable the, again, that's if there's an error, and then we return the pretty JSON, which is again matches the interface because the interface is anything, and then basically that's the function that's being wrapped, and then we're returning the JSON function. So essentially what this does is going to take that function and return to us the JSON, the JavaScript wrapper, or the function in the JavaScript wrapper. Okay, I get that. Cool. Okay, let's walk through that same logic. Okay, now let's see here. We assign funca, we return the function, we're ready to call for JavaScript. We need to expose the function we just created so that it can be called from JavaScript. The way we will expose that Go function to JavaScript is by setting the format JSON string property of JavaScript's global object, the JS func return, to the js.func returned by JSON wrapper. The line of code that does this is js.global set format JSON to JSON wrapper. Okay. Now, is that something that was already in there? I don't remember seeing that line. Okay, so I'm assuming we're going to have to add that. Okay, so this here shows us where that's going to get added. Okay, func main. So we have those two functions, so we just have to add this line in our main. And this takes the JavaScript global object. The global object has everything that has like global scope in it. Not there. We put that here. So it's saying, hey, in the JavaScript global object, we're going to set a property called format JSON, which is going to be our function to the result of the JSON wrapper, which again wraps the function. And again, so essentially taking this function and makes it usable. Okay. Now let's compile and test the program. So again, we have to run all this. Okay, so I'm going to want this again. Copy. Because again, when you want to compile to Wasm, you always have to set these two variables. Okay, and actually I want to do that in this folder. So let me open up the terminal in this folder. Okay, so I'm going to want these two environmental variables, and then I'm going to say go build, and then the output should be o dot dot slash dot dot slash assets slash json.wasm. Okay, and I think that should be good. Actually, specify the folder. Go build. We'll just first run this and see how it goes. Cannot find main module, but found. Okay, so let's try this again. Go build main.go. Main files must be .go files. Oh, I think that has to be the last argument, that's why. Main.go. Package JSON is not in Go root. That should be. Okay. Oh, it's encoding JSON. Boo. We did a video on JSON already. We've been through this. Okay, well, you can't remember everything all 100% of the time. So let's try that again. Okay, so that should do it. And see, like, that changed. So we got that little coloration to show that has been edited. Okay, cool. So that has been compiled. Okay, now the complete program is provided below. JSON wrapper. Okay, now calling the Go function from JavaScript. Okay, we already have the bindings. The reason that the error mentions is our Go program has already exited when it was called from JavaScript. How do we fix this? Well, let's see here. We have exposed the Go function to JavaScript successfully. Let's check whether it works. Go to the browser, open the JavaScript file. Type the following command in the JavaScript console. Okay, so let's see here. First, we need to run the server. So let's go to new, open and integrate terminal, and to go run server.go. Let's run our server. Oh, let's go run main.go. Run main.go. Okay, that's running. And that's going to be running on localhost 9090. So let's go to localhost 9090. Okay, and then, oh yeah, if we want to look in the terminal. And we see here, failed to the server responded with a status of 404, and there's the message. And what this wants us to do is here in the terminal is try out this function. So let's see here. Let me just, does it give me the call? Yeah, here we go. That way I just don't have to write all that JSON out. Okay. So I'm going to paste this function in there. There it is. And theoretically, it should give me back the formatted JSON, but it says Go program has already exited. Okay, so basically, the deal is that that program ran and it was done. So let's see how we deal with that. The above command calls format JSON, JavaScript function which we exposed and go past is bummer. Okay, we did. The reason is the error mentions that our Go program has already exited. So we need to figure out a way to make this. The easy way to do this in Go is to keep waiting on a channel. Okay, well, it's pretty simple. We just must ensure the Go program is running when the JavaScript calls it. Okay, so what we're going to do is we're going to make a channel. We haven't talked about channels yet in this series, but a channel is just essentially a open process, parallel process that can receive messages. So we're going to make a channel called bool. Okay, and we're just going to wait on that channel. Please add that last line, compile and rerun the program. So I'm going to go back to that other terminal. Boop. 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 Back to main.go. We add this one line. And essentially what this does is just means to make something. What are we making? A channel. And then this little symbol is like for channels. We'll cover that at some point. Something I'm still fully wrapping my head around. But essentially I think of it as like one way in Go to do like parallelization. Where you say, okay, we have this code going over here, and you have different channels of things going on, and they can pass messages back and forth to each other. Yeah. Oh, asynchronous code. Okay, so we put that there. Now let's recompile. So I'm gonna stop the server in this terminal, and then go back to this terminal and recompile again. Okay, so that's compiled. Now back to this terminal and run the server again. Okay, and now let's refresh. Okay, see, that's looking happy. And now let's go copy that function call again, right here. Now let's see here. And it works. So we get the nice pretty version of our JSON. Okay. Well, this is like the return value. Okay. And then it's console logging this input. Let's actually go back and take a look at the Go program here, the function that was written. So printf input JSON. So that's inputting what the first argument is, which is JSON, the JSON string. So that's essentially what that's doing. So that was the argument, and then we end up getting this, and see like there's tabs in certain places. Like after the new line, you'll see like just tabs, nothing too crazy there. Yeah, so that did what it was supposed to do, nothing too exciting. And so we fixed that. Now the JSON will be formatted and printed. Essentially that's what we saw. Doesn't quite look that way because we're seeing the format strings. So let's see here. Format JSON, we will get the message valid, no number of arguments passed. Okay. Let's try that. Format JSON, valid, no number of arguments passed. Okay, so that works as expected. That's pretty cool. Okay. And that's that. I think that's pretty much the end of the tutorial. Great, we've successfully called a function from Go, the JavaScript. So then theoretically, you know, like here they have like, I think here we can go to the DOM access and error handling. So maybe we'll do that in upcoming, we'll continue from there. Let's switch back to Rust. So in Rust we kind of did the same thing except with an alert. So let me just walk back through that. So let's just close all this, kill the server, start killing all these things. Main.go. Let's just trash all these terminals. Okay, now in Rust, close all. Okay, and where's the Rust WebAssembly? Here we go, Wasm game of life. Okay, essentially we had our source. In our source we had our lib.rs. Okay, and let me just kind of wrap my head around all this. Basically all we wrote really was, So essentially what this is if features enabled, use reallocate as a global allocator. So I'm assuming this is allocating stuff in the global JavaScript object or global memory. I'll have to read up more on that one. But essentially this was to expose functions from JavaScript. So this brought the JavaScript alert function into our program, and this allowed us to export a function. So we use that alert function in greet, and then was able to use that function and create this function that uses alert. Okay, now here this was already, because again we use this like Wasm template that's they have for Rust, so a lot of this stuff is kind of already set up. But then we compiled that, and we compiled it to this bin folder. Okay, and then let me see here, bin create wasmapp.js. Oh, this is like this was actually a front end application we generated using a template, and essentially right here, create wasm.js. This create wasm git cloning template failed. No, that's not what I'm looking for. What we did do is we ended up installing that. So was it like, I called it something. Well, we ran something that installed it into here, and then we were able to run this program. And then and again, this index.js imports that Wasm game of life library, which was again the code we compiled from this folder, which is, I think this is the this package folder. That's the compiled files. And then maybe we were able to run that function we created as wasm.greet. So again, it gets compiled, got put in the package folder, created this front end project, we installed that folder as a package, and we're able to use it. And I think it's like this bootstrap function. I'm trying to think where. Yeah, I guess that's just basically how it's done. So go back to index.js, Wasm game of life, because it's all imported as a module, a JavaScript module. Because in this package JSON folder, basically we have this Wasm game of life deal. Again, this is the compiled code. Okay, get string from Wasm. Again, you get this function here. Yeah, and I can import it directly from Wasm. Okay. I see. Always things that are just a little bit harder to like see clearly initially in Rust, but all good. Let's go to the next section and kind of continue from there. So this just explains you what the game we're building is. I'll let you guys watch that if you want to do so, but let's just continue with the build. Okay. Copying in and out of the memory. Okay, this is going to get into some find the array. Okay, here we go. We clone the initial product template. We modify that project template now. Let's begin by removing the alert import and greet function from Wasm game of life and replacing them with a type definition for cells. Okay, so essentially we're going to copy this and we're going to move that over back to our source and lib, and we're going to get rid of the greet and alert piece. And again, anything we use is wasm.bindGen attribute. That's basically binding it for Wasm purposes. Okay, and we're creating and again, this just derives a bunch of attributes, so that way it implements these traits, so these functions are available. But we're creating something called a cell, which has two properties. Well, actually, this is an enum. So that enum just means like a set of different possibilities. So there's dead, which is 0, and alive, which is 1. Okay, so those are the two possibilities in this particular as a cell. So a cell is either dead or alive. Now it's important that we have the repr u8 so that each cell is represented by a single byte. It's also important that the dead variant is 0 and that the alive variant is 1, so that we can easily count a cell's live neighbors with addition. So essentially what it sounds like what we're recreating is Minecraft. Not Minecraft, Minesweeper. Now let's define the universe. The universe has a width and a height, and the vector of cells and length, width, and height. So copy that in there. Again, we're doing the whole Wasm binding. So that's just going to generate the Wasm bindings for us. Pub struct universe. Okay, so this is a struct that has two properties, width and height, which are both unsigned 32-bit integers, and then the cells, which are a vector of cells. Okay, so that's cool. To access the cell at a given row and column, we translate the row and column into an index into the cell's vector as described earlier. Okay. Oh, that's not the whole code here. So we'll do this in pieces. Copy. So what we're doing is we're going to implement universe. So that means we're going to add methods to it. So function, first we're going to have a get index function, which allows you to set a row and specify a row and a column. And then it'll return the row times self.width plus column as usize. So it just basically is an unsigned integer of, whatever the size is. Okay. And then we're also going to want this function here, live neighbor count. Okay, function live neighbor count, that takes in a row and a column. And looks like what it's doing is just going around, checking all the cells around it to see what is the value of all the live neighbors. If you ever played Minesweeper, essentially the way Minesweeper works is you would see a square, and the square would have a number that represents like how many bombs are around it. Okay, or how many, and then basically using that, you would like have to kind of determine sort of where the bombs are, because like if this one says it has like so many bombs next to it, and this one has so many bombs next to it, you can kind of reason like certain squares are not going to have bombs because the numbers wouldn't make sense. So that's essentially what this is doing. It's just counting the number of dead live squares around. Okay, thus live neighbor count because of the neighboring cells. Okay. But let's see here. So we start off with a count of 0. So we start off with a particular row. And then we're going to loop over all the columns in that row. And then we find the column. And then we're going to loop over that column as well. And if the row is alive and the column is alive, and again 0 means dead. Oh no, they're both dead. Then continue. Okay, let the neighbor row equal row plus delta row modulo self.height. And okay, so it's just getting the different rows. So the index of those rows. Let the index self.get index. Cool. And here's going to get those indexes. So I guess I'm assuming that's where it continues from. Count self cells as you ate. Okay. So essentially it's going to go in there and add the value of the cell. But again, if the value of the cell is 0, it's going to add nothing to the count. But if the value is 1, so you're just essentially taking the count. Starting from 0, you're looping through all the squares around that cell, and you're just adding the value. Because the result should be, the live cells should add 1, the dead cells should add 0. So that's essentially the way that works. And then it returns the count. Okay, so that's how that works. Okay, Wasm bind gen. Okay, let's see. Public methods exported. So I think this is just what we just did. Or no, this is another one. Universe function tick. Now we have everything we need to compute the next generation from current one. Okay, so then this one. So those functions are just like supporting functions, but we want another implementation block because these functions will actually be exposed to JavaScript, meaning we can then use them in the JavaScript. So that's why it gets a separate implementation block. Although, I have a feeling I'm missing another curly bracket. So let me fix that first. And then we put this other block. Okay, and in this block, we're implementing universe. But again, this always creates the bindings to Wasm. So that way it can be either you're bringing in from JavaScript or sending to JavaScript. or really exposing or receiving from the browser, really. Okay, function tick. So next cells dot clone for every row 0 self dot height. Okay. So far, let's say the universe is represented by a vector of cells. To make this human readable, let's implement a basic text renderer. The idea is to write the universe line by line as text, and for each cell that is alive, print the Unicode character black medium square for dead cells. And we put it for medium square for live cells. By implementing the display trait from Rust standard library, we can add a way to format a structure in a user-facing manner. This will automatically give us the toString method. So let's see the way it does this. Implement. Well, first we need to import that. So let me just go put that at the top of the file. And then let's bring this in. By implementing the display trait from Rust standard library, we can add a way to format structure in a user-facing manner. So let's just add this here at the bottom and take a look at it. Okay, so this is another implementation block, and what this implementation block does is we're implementing this trait for universe. So that means the display trait has a function called fmt that's necessary. So then we're going to implement that particular function, that display function, or this fmt function for universe. Okay, for line itself cells, and this is just kind of determining what's, and this is determining what to show text-wise when they show the universe. Okay. Finally, we define a constructor that initializes the universe with an interesting pattern of live and dead cells, as well as a render method. Okay. So this is in that previous implementation block, because this is the implementation block with the Wasm bindings. So I'm going to copy just the necessary code over to it. Okay, so this is the constructor. That's the new function. Okay. And that's going to be called, that basically creates a universe of width and height 64. Okay. Let cells equal 0 width to height. So that's going to construct the vector and say the vector is going to be of that many cells. Then it's going to map I if I modulo 2, and okay, this determines which cells are live or dead using the enum. So it's going to give it a 0 or a 1. And then it returns, so here's just determining the values, and then here it actually returns the constructed struct. Okay, and so that makes sense. Oh, and let's go back to that render function. And render just basically takes self dot toString. So that just basically generates a struct to a string. Okay. And that's going to be possible because we implemented the display trait, I think. Or let me just take a look back to when we first created the struct. Yeah. Okay. So rendering with JavaScript. So first let's add a pre-element. So let's recompile it to WebAssembly by running Wasm pack build within the Wasm game of life directory. So let's do that. So we do Wasm pack build, because again, Wasm pack is a tool we use for working with Rust and Go. I mean Rust and WebAssembly. So Wasm pack build. Oh, didn't like something. Not a member of trait. Format display. Oh, I put it in the wrong block. Did I? Let me see here. Which block does that belong in? Oh yeah, but I put it in the display implementation one. So let me take these out of here. That's not where this goes. That actually goes here. There we go. Let's try this again. Okay, good. That was successful. Okay, you can't define a method that wasn't, in a trait implementation block that it doesn't actually belong in the trait. So that was my issue. I put in the wrong implementation block. Cool. So let's go to the next step. Okay, so we recompiled it. Now we need to go update our JavaScript. So we're going to first add a pre-element to our Wasm to render the universe into the just above the script tag. Okay, so basically we're saying here pre. So let's go in there and do that. Let's go back to www. Let's go find our HTML. And that seems to be replacing this. Well, actually, no, it's replacing the body. So, boop. There we go. So this element here is basically where we're going to inject the canvas. There's just our bootstrap JS file. Okay, additionally, we want the pre-centered in the middle of the web page, so we can use some Css Flexboxes to accomplish that. So we'll just copy the style tag in there. Add the file stat tag inside the head tag. Oh, okay, that's a way to do it. Okay. So that's there. I'll just save this so that way it makes it all nice and pretty. Good. And we're going to import universe from Wasm Game of Life in the JavaScript file. Then we import the function we created, except we don't need Wasm. One second. How do I think about this? Now that we recompiled it, do I need to reinstall it? Within the Wasm Game of Life directory? Well, it didn't tell me to do that yet, so I'm not going to assume. At the top of the Wasm Game of Life, www.index, let's fix our import and bring in universe rather than the old greet function. Okay, so let's do this. Boop. Yep, because we're just bringing in a specific thing from there. Okay, and also let's get that pre-element just added. Okay, so let's do that. Using getElement by ID. Okay. Let us get the element by the ID. So this is grabbing the pre-element, and then we're creating a new universe. Okay. JavaScript then runs a request animation frame. That runs in a animation frame loop on each iteration. It draws the current universe to the pre, and then calls universe.tick. So that's what this function is going to do. Render loop. Okay. So we're going to define this function. So what this does is say pre.text content. So we're going to put the universe.render in the text, the result of that render function we defined earlier. And then universe.tick, which will just kind of keep moving through the different things. Request animation frame, render loop. Okay, so that's just going to make it be recursive. To start the rendering process, what we have to do is just make an initial call to the first iteration of the rendering loop. So we just do, oh, that's already in there. So make sure your development server is still running. Do an npm run start. Okay. So let's go start the server. So I need to be in here and do an npm run start. And again, which localhost 8080. So let's go to localhost 8080. And I don't see any errors. I see the pre. Okay, so assuming maybe we do need this a call to this on the outside. Just to start that first loop. Yeah, there we go. And that's kind of nice, but it's kind of going on forever. But it looks cool. Okay. I want to stop that server now. So that's just a recursive loop, but it's cool looking. Should probably stop this. Refresh. Okay, just that way it's not doing all that anymore. Okay, string and rust, and then having Wasm bindgen converted to a valid JavaScript string makes it unnecessary copies of the universe cell. So as the JavaScript code already knows, you can read WebAssembly's linear memory that makes up the cells directly. We'll modify the render method to return a pointer to the start of the cells. Also, instead of rendering Unicode text, we'll start switching over to the Canvas API. We'll use this design in the rest of the tutorial. Okay. Aside, let's replace the pre we added earlier with a canvas. So let's do that. We're going to add the canvas. Canvas is a HTML element that allows us to kind of draw things. So we replace this with a canvas. I have to learn what the pre element is. That's a new one to me. Okay. To get the necessary information from Rust implementation, we'll need to add some more getter and setter functions to the universe's width. Okay, so we're going to add these over to that the Wasm implementation block. So over here, that's this block here. So right after render, boop. So that we added some getters. The next in the Wasm Game of Life index, let's also import cells from the Wasm Game of Life. Also define some contents. So let's copy that. And then that's in here. We're going to also import the cell that was defined in one of the implementation blocks. And I think we're going to want to do this up here. Cell size, grid color, dead color. So that's going to be all used for when we do the canvas. Now let's rewrite the rest of the JavaScript code to no longer write pre's text contents, but instead draw to the canvas. Okay. Okay. So that's going to be all this. We're going to replace this with this. Const canvas document.getElement by ID. So we're getting the canvas. Then here we're determining the canvas's height and width, which we're using the cell size for. Then we're getting the context. We're saying the context of the canvas is 2D, not 3D, because you can do 3D stuff there too. Then we're going to do the render loop and universe.tick, draw grid, draw cells, and then it will request animation frame render loop. Okay, and then just kind of keep animating that way. To draw the grid between cells, we draw a set of unequally spaced horizontal lines and a set of equally spaced. These lines cross into the form of a grid. So we'll add that in there as well. Although, if I find that there, because draw grid is called in here, so that would need to be defined beforehand, because that's an arrow function. And then we also need to define a function called draw cells. Okay, and this just does mathy stuff to get to the thing. I'm not going to get into algorithmic stuff here. We just want to know general gist of just working with the language. Okay, let's see here. This looks like it's a different file. So let me figure out what file we're in right now. The draw grid between the cells, we did that. We can now directly access WebAssembly's linear memory via memory, which is defined in the raw Wasm module. To draw the cells, we get a pointer to the universe's cells. Construct a event array, pointers run every tick. Okay. To start the rendering process, we'll use the same code now. But what file do you want me to do this in? Draw cells. There's the draw cells function, so I would kind of need it. But I see you have to import it from here. This has to be imported from here specifically. That's a different import than the one we have over here. Because it's from the life background stuff, so that's the access to its direct memory. And then we add all this. Copy it. I'm going to put this again before. Actually, I guess technically I didn't have to define it before because all these functions would be defined before the invocation of it. But I'll still do so. So I'll put this right after there. Save it, let it kind of clean itself up a little bit. We'll use the same code as the above to start the first iteration of the rendering loop. Draw grid cells. So then we just put one invocation to get it started. Save. I need to rebuild, so of course I need to go rebuild the Wasm bindings. So I think I got this terminal over here to do that. So Wasm pack build, that recompiles it. Then I can go over here and restart the server with Webpack. Oop, module parse failed. Identify universe has already been declared. We need to appropriate loader. Which file is this in? Bootstrap.js. Universe.new. Okay, so let me get rid of this line here. I need to do that twice. Okay, so let's try that again. Okay, now it likes it. Now let's go back over here and refresh the page. Oh, and that's pretty cool. Okay, it's generating this nice sort of animaty effect. And again, this was all essentially programmed in, like the struct and all this stuff was all programmed in Rust, which allowed you to like really kind of like type things and make really efficient use of memory. And then we import those bindings over the JavaScript and then just use them in JavaScript. So that's pretty cool. So you can create like really like fast or custom kind of like functionality and import them in JavaScript as functions that you can use, but were built in another language. I mean, I know you could theoretically kind of do that in Node already with like C and C++, and you can do that same thing like Python, where you can use like C to kind of build functions that do things that you couldn't before, but that's cool. I'm going to stop that server though. Okay. Even though the browser's doing the work, but yeah. Now we're done with this section of the tutorial. It works. So we did all that. We see this. Good. As an aside, there's also a really neat algorithm for implementing game of life called a hash life. Exercises. Cool. Okay. And I think we're good here. Again, we'll continue on with this tutorial throughout. So I might do another video, but I think this is all good for day 19. So I'll see you guys later on. But again, the general gist here of Wasm, and maybe we'll move on to something else. I think we got the point here. If you wanted to learn more about using Wasm in Go or Rust, you have the basic idea that essentially what you do is you write the code, you compile it to Wasm, then you import it in JavaScript or somewhere else, and you can make use of it. But there's a lot of other stuff in these languages to learn, so maybe we'll start doing that. But this was fun. Kind of cool to get some exposure to Wasm. You guys have a great day and enjoy. My name is Alex Merced, and enjoy.